2.0 week. Today, we share the published high-quality work on the utilization of artificial intelligence to tackle solid waste management aligned with Guatemala's National Development Plan. At the UN, as stated by Secretary General, UN 2.0 Quintet of Change, New Vision, we embrace a forward-thinking culture empowered by cutting-edge skills for the 21st century to potentiate our support to people and the planet. At UNDP, as stated in our digital strategy, we seek to create a world in which digital is an empowering force for people and the planet. As our strategic plan outlines, UNDP seeks to support country in three directions of change: structural transformation, leaving no one behind, and building resilience, underlying the importance of digital as one of three enablers to achieve this change. In Guatemala, the implementation of participatory actions in the integrated management of solid waste at the municipal level is listed as one of the strategic goals of the National Development Plan and the country priorities. The Ministry of Environment and Natural Resources and UNDP in Guatemala have focused on the establishment of baselines and indicators in the areas of biological importance in fluvial and marine coastal zones, such as the Motagua River, which is the largest river in the country. Unfortunately, this river also carries a high volume of waste. And UNDP Guatemala has been experimenting with digital innovations to inform the design, the implementation, and monitoring of solid waste management interventions. In that regard, I would like to highlight the cross-disciplinary collaboration between UNDP Guatemala, UNDP Istanbul Center for Private Sector in Development, for developing a low-cost and scalable digital solution for addressing solid waste management for the Guatemalan context. Also, I would like to give a special mention to the Politecnico de Milano in Italy and as an academic support for this effort. Since July 2023, UNDP Guatemala and SDG-IE Lab initiated a fruitful partnership for identifying legal waste dumping sites in Guatemala, particularly alongside the river basins and water resources. We have reached a key milestone for advancing emerging technologies, particularly artificial intelligence, to tackle sustainable development challenges with human-centric approach, emphasizing scalability for the design phase, seeking to empower local authorities and communities. I would like to thank you all for joining us today. We hope to serve as a stepping stone and looking forward for further scaling digital innovations and advancing further analysis related to multidimensional poverty. We invite you to reach out to us and should you like to be part of this journey and should you have any questions. Thank you so much, and let's hear from the experts. Thank you.
Thank you very much, Rose, for your kind welcoming words. Welcome, everyone. Thank you for attending. For those who have just joined, we have been asking if you could include in our chat the name, your name, the name of your organization, and where you're located. So we also have a sense on to better address what we're going to be discussing in the future. So, and just to give you like a rough map, right, and the steps, the agenda that we have planned for today's session. We're going to be hearing from Federico Gularte about the context and problem description. He's a specialist here in Guatemala from the Ministry of Environment and Chemical Products as well. That will be followed by our SDG AI Lab specialist, Martin. And then we will get into some final remarks, reflections, and mainly learnings based on what we have done so far. So without further ado, I will give the word to Federico. So please, Federico, if you're mute, you can unmute yourself, and the floor is yours. Over.
think you're still muted.
Carlos, can you hear me? Yes.
Yes.
Okay. Good morning. We are here to talk about the big problem, pollution of Motagua River. It is an urgent issue for us to environmental and for people. As Carlos said, I am Federico Gularte, a specialist of chemical and waste management. We are acting now to help this important river in Guatemala. Look at this picture. It is more than just a photo. It is clearly show a big problem with how we manage our environment. Because in Guatemala hasn't put a good policies in place for managing dirty water and trash, or important rivers like the Motagua are now carrying huge amounts of waste and harmful stuff straight into the Atlantic Ocean. Next. Okay. In this project, our goals are to reduce land-based pollution sources and persistent organic pollutant emissions, thereby mitigating impacts of coastal marine ecosystems and local livelihoods. Next, please. This project is a team effort, as you know. It is led by United Nations Development Program, gets help from Global Environment Facility, and is solely supported by the Guatemalan Minister of Environment and Natural Resources. It is structured this way to face it: geological scope, socioeconomical context, biophysical context, diagnostic analysis, and a strategic action plan. Next, please. Let's delve into geographical scope of our study, a fundamental starting point for understanding the scale of this challenge. Here we can see where is Guatemala in the globe and where is Motagua Basin is located. It's covered an area of 70,727 square kilometers. Next, please. Transition to the economic context. There are many analysis variables. Here we can show just four. As shown, the demographic reveals an nearly balanced distribution of men and women. This map illustrates the distribution of the school sites within prioritized areas in Motagua project. The Motagua Basin is tapestry of diverse linguistic community as well. A truly impactful environmental management strategy must honor and integrate these rich cultural concepts. Lowest solid characterizations means that there are poor governance activity related. Next, please. Here we can see where are the illegal dump sites and how they have changed in the last 5 years. We can see low reduction rates. Next, please. Now let's turn onto attention to some of the biophysical context of Motagua Basin. This encompasses of natural system and ecological process that define this vital region. Understanding this element is fundamental to any strategy aiming for true environmental restorations and conservation. We need to appreciate this intricate web of life and natural resources that we are working to protect. Next, please. Having established the context, we now move to a crucial phase, the diagnostic analysis. This involves a rigorous examination of the interconnected problems plaguing the mountain basin, delving into the root causes and meticulous mapping out their wide-ranging effects. Only through this deep understanding can we develop truly effective and targeted intervention, like low water quality, land use change and deforestation, climate vulnerability and risk to extreme events, with governments and high level of multidisciplinary prevent and inequality. Next, please. Our strategic objectives are pillars of our action plans. Object 1, improve water quality by integrated waste management. Object 2, protect and restore Motagua natural resources. Object 3, climate resilience, reduce extreme event risk. Object 4, reduce poverty, inequality, boost opportunities and service. And Object 5, inclusive Motagua environmental governance.
Thank you. Thank you very much for that. And just highlighting the importance of this of the protection of environment, as we have just heard from our environmental and chemical specialists, and as well as what kind of solutions is there in terms of digital and data solutions could somehow help us to tackle this problematic that even covers like a larger geographical area than only Guatemala as a country, but in our region as well. So right now we're going to be hearing from Martin Sigeti from SDG AI Lab team, who have partnered with us, UNDP Guatemala, in collaboration with the government of Guatemala as well. He's going to be explaining about the technical solution that we have both co-designed together with local authorities, and at the same time we have implemented for the context of our country. The floor is yours, Martin. Over.
Thank you so much, Carlos, and the previous speakers from the government and also from UNDP. My name is Martin Sigeti, and I'm working as a GIS and data science analyst at UNDP IICPSD SDG AI Lab. And I will quickly introduce the lab for your reference. This is a digital solutions innovation lab for sustainable development goals, which is sitting in Istanbul, but we are active globally. It is hosted under UNDP ICPSD, so International Center for Private Sector in Development, and we are harnessing the potential of frontier technologies such as AI, machine learning, and of course GIS for sustainable development. We are strengthening the internal capacity for UNDP to respond to this increasing demand for digital solutions, and we provide various services. For example, we are working in the development of new technologies and refinement of such technologies for the application in the SDG areas. We combine this with research. We are reviewing available technologies, and we are implementing them for these development challenges. We provide advisory for units, UNDP units, but also governmental partners. And we are facilitating partnerships between UNDP and the private sector. Of course, we also offer trainings. We have some good examples. For example, Frontier Tech Leaders, which is teaching international cohort of students the application of machine learning for sustainable development challenges, but also collaboration with private companies such as Samsung and Innovation Campus. So all in all, we are a one-stop shop for all digital solutions regarding UN and UN network, and also private sector from UNDP. With this, I will move on to the presentation of the technical solution. So based on the, let's say, inputs you heard from the previous speakers, and they set the scene to understand what we were working on. So we developed a technical solution to understand this type of context and facilitate the efficient and cost-effective monitoring of environmental hazards. This environmental hazard that we are talking about is especially the dump sites and the illegal disposal of trash and wastes in the environment. You can see an image on the left-hand side. This is typically how it looks like, but it can also be a lot smaller or larger. It depends on the context. So we offer a high-quality technical solution to utilize the latest computer vision models, but we also developed it in a way that is scalable and time plus cost-effective, which are all very important measures for the success of such a solution. Of course, as I mentioned before, we are also improving the internal capacity for UNDP, and we own this technology since we developed it ourselves. It is a real-life problem, and of course, you have seen the various challenges that are resulting from this problem in the country. For example, in Guatemala, the environmental pollution and other problems that come with this. The groundwork was laid by an organization called Peraviglion in combination with the University Politecnico di Milano in Italy, and they worked together to collect the data set, which was also on illegal dump sites, because in Italy there is a similar problem. And they connected more than 10,000 samples, which then they used to train a model, a machine learning model, to predict and understand these types of dump sites from satellite images. So by looking at satellite images, this model is able to distinguish dump sites from other natural and unnatural types of land cover. For example, the difference between dump site and, for example, industrial zones or streets and buildings. We used this data set and we transformed it into a new model using the data sets provided by the government in Guatemala and Guatemala Accelerator Lab. And this model is based on a binary classifier, which means that it can distinguish between two different classes. Is it a dump site or not? It's using a ResNet 50 convolutional neural network model architecture, and I will give you a little bit more details on how this exactly works. So there was a knowledge transfer from the Italian dataset to the dataset that we received from Guatemala, and this was fully written in Python, so it's totally easy to transfer and understand. There's no proprietary technology involved. Anyone can work with this. And we had to manually validate some training points in the case of Guatemala, but successfully did so. And also we actually moved away from the proprietary satellite technology that is necessary to train the previous model, and we used Google Static Maps API satellite images. So these images are actually not for free, but they're much more affordable and can be used from open source, not open source, but from Google Maps, of course, at a lower cost than high resolution images are typically. So we went into an experimentation phase. First, we used the available model. We tested it on these new data sets, and we ran a long training process, which after the successful training, we tested with the real data, and we also achieved a quite successful precision. So this is the model architecture. I think it's relatively small. But it's built on ResNet 50. So this is a convolutional neural network with 50 different layers, and it's enhanced with something called FPN. This is the so-called feature pyramid network. And this design offers several advantages. So it is leveraging residual connections between training for improved training and performance. And the so-called FPN architecture is improving the performance by combining low resolution features with high resolution semantic features. So this combination is creating a multi-level feature extraction system that excels at identifying features at various scales. And this is exactly what we need, because the input images reflect, let's say, a very multidimensionally resolved problem. The dump sites can have very different features, so they can look very different, and we need to be adaptive for different resolutions and input data. So we also did a process called transfer learning and some adaptation to the existing code. We restructured the module by using PyTorch with the so-called Lightning module. We created custom training scripts and also made it possible to adapt the model with more incoming data, because for this specific case in Guatemala, we were able to afford some data, but if you want to train this model in a new country, a new environment, you may need additional data for doing so successfully. The rest of this solution, of course, is utilizing the cutting-edge standard methodologies. We had a few thousand input data sets from Guatemala, and you can already see that the previous implementation by the Italians was using high-resolution satellite imagery, which, if you have it, is very nice to work with. But if you want to use it for a different context, you have to buy it, and it costs you thousands or even $10,000s of dollars, and that will be very expensive. So we use the Google Maps Static API, which for the amount of images we required for this training process, I don't even think we paid a single dollar. But of course, if you go beyond the free tier, you also have to pay money for Google. So we actually looked at the data points that were provided by our partners in Guatemala, and we manually inspected them by overlaying the dump site locations with the satellite images from Google, and we were like looking if we can actually visually identify suspicious sites. In many cases, we were able to do that, and we had to this way reduce the amount of data quite significantly, because a lot of times we were not able to see a dump site, or it was covered by some sort of canopy, or maybe it was just below a tree, so we couldn't see it, unfortunately. We downloaded the data set with some generic scripts. As you can see here, we have the locations, and we just run this little environment, and it will then automatically download images. You can see the speed of the download is quite fast. Now you can see that images are popping up in the folder, and it will just create 1,000 pictures in a few minutes, and you can already look at this result in this case. An interesting way to look at these results is to take one of those pictures with the suspected dump site and run it with the model, and the model will output something that is called class activation map. And this heat map is showing you the certainty of which the model believes that there is a dump site in the image. And it also tells you where it is, and also how strong it is confident about the dump site. And sometimes you can see there are some false activations. Sometimes it is mistaking, let's say, a settlement with a dump site. Sometimes it is mistaking dirt and rubble and other types of land cover with dump sites. But usually when it goes into this reddish color, it means that the certainty of the prediction was very high, up to 90%. And in these cases, if you check the result, you will find that most of these are actually correctly classified. However, of course, there are always a little bit of misclassifications in such models, and you can improve this by adding more training data, better training data, and also improve the resolution of the input the pictures, for example. There are various methods, but in this case, with the limitations we had, we managed to obtain a reasonable result. There's another way to visualize accuracy. Of course, you can use the confusion matrix, and this shows you the different types of errors that a machine learning model can do. And you can see that in this case, all of these different types of accuracy metrics, we call precision, but also the F1 score, which is a combination of both, actually ended up in around the 70% mark. The original model with the, let's say, optimal data sets, it's performed around 90%. Actually, it was quite high. In our case, sometimes we were reaching the 70 and 75% as well. It depends on the sample. And this means that we were able to classify a lot more images correctly than not, which is, of course, very important. There's also learning curves for such activities. Learning curve can show you how the model is, let's say, over the time of the training time, how well it actually manages to generalize the data that it finds. And also by shuffling the samples that it is using for the training process, you can see if sometimes there are very large spikes. There might be a problem with the balance in the data set and other things. Maybe the overfitting can occur, which are also things that you have to account for. In our case, the training, let's say the sample size, the training sample size was not very high. So we might be able to improve this also by adding more training data. Also, one important aspect of developing such technologies is like transforming it into something that you can play around with. In this case, very quickly, we were able to like set up such a graphical user interface where you just like select an image, and you want to know, is there a dump site or not? And you would just put it into the system and click classify, and then it would just give you a probability of, in this case, 0%, for example, which is correct. And there's another example showing this one. I think there is a dump site somewhere. It's very small. Let's see if the model finds, actually, it predicts a 93% probability that there's a dump site in this image. I think this one also contains dump sites. Again, 93%. And as we move away, the technical takeaways of this model were numerous. First of all, we were able to show that we transferred this model from Italy to Guatemala, which is already an interesting step, which might also be relevant for future implementations if you want to move it to another country again. And we managed to overcome some of these challenges. For example, the necessity to procure high-resolution images might be a thing of the past. And combining this like modern technology, ResNet 50 architecture with the feature pyramid network, it was able to improve or like even further improve the sensitivity for this prediction. And then even though we had some, let's say, technical challenges, I think our model achieved the promising result, but there's of course still like room to improve. And that's it from my side. Carlos, do you want me to switch the slides for you, or you want to present yourself?
I can present myself. Thank you very much for that.
Okay.
So thank you, Martin. So just trying to go back from the beginning of the presentation, we have gave you like a picture of the challenge, like a big challenge, the environmental challenge that we face in Guatemala and similar to other countries in the region as well. And as well, this collaboration between UNDP, Guatemala, and SDG AI Lab on the specific solution, like pretty much AI-driven and computer vision that we have co-deployed together and is at a current stage that is like cost effective and can be scalable to different regions as well. So as I give you like some reflections, let me know in case you cannot see properly my screen. Yeah, you can see that, right? So
I'm sorry, I need to stop sharing, I think.
Okay.
Yeah, that's why. Now you can share your screen and you can see it after that.
Okay, I see. Then give me one more second then. Okay, so you should be able to see it now, right?
Yes.
Thank you. So we're also like at UNDP, we do have these R&D capacities, like capabilities in terms of sustainable development. We're part of a global network, which is the Accelerator Labs network, and is somehow we have presence in over 100 countries. We're 89 teams, just potentializing and pushing forward this kind of new ways of thinking and approaching sustainable development problems, just as the one that we have shown to you. This is just like a general map where you can see like all of the different solutions that are being tested in some of these countries and specifically related to digital and data technologies. The link is there for you in case you want to like dig in a little bit deeper. And there was actually one session, a parallel session yesterday, in case you want to check it out as well from our Accelerator Labs global team in terms of artificial intelligence and collective intelligence. But just to give you like an overview of what we're doing here is that we are utilizing different data sources as it's shown at the top of this image in terms of Earth observation, imagery, network data, and social media, for instance. And when you combine that with different computational techniques, just as object detection or computer vision, as we have just here from Martin today, it's very interesting what can happen and what's possible in terms of the application areas that are related to sustainable development. So for instance, in the case of Guatemala, I know it's a bit hard probably to see here, but it says like environmental monitoring that connects with the example in Guatemala that we just have shown. And the idea of this picture is just to give you, again, an overview that other type of computational techniques combined with different type of data sources are also being utilized in other domains. We invite you to learn about that as well. Also, as you might be aware, UNDP recently released its Human Development Report, and the 2025 report of this year highlights the artificial intelligence at the intersection of human development. And one of the key messages is that it's a matter of choice in the sense of understanding what are the possibilities and the impact for people and the planet, and the outcomes of technological change are not inevitable. Those are happening, but they are contingent to these like social choices. So it's really up to us on understanding what are the risks, what are the possibilities, and what capabilities from our own organization, from our own position, we have in terms of choices on how we utilize this to potentialize these benefits, but at the same time minimizing risks in terms of like human development. Now, going back to the main topic, we have actually have some key learnings that we want to share with you. As Martin explained, the first one is related to the data that we analyze in Guatemala. So the algorithm, the model, the computer vision model was mainly trained from samples um, from Guatemala as reported by the central authority in terms of environment. And after analyzing that, we realized that actually the location, the geographical location of illegal dump sites were actually non-randomly distributed. So that means that it somehow showed some sort of predictive factors that is possible to anticipate on where that could happen based on an imagery that we have at hand, right? In this case, like satellite imagery. So this is one of the key learnings from the data itself. A second learning is that, as Martin also explained, we employ a specific architecture that can actually be applied and somehow generalized to other similar contexts with relatively little effort. That's pretty much like it's coming from all of the research that Politecnico de Milano and some models that initially were deployed for that specific context. So we adapt that and then we somehow transfer that learning to the local context and adapt those models. Of course, it's very important to know at this stage, at this point, that having the enough data samples, like representative data samples, is very important. And that directly relates on the performance of the model that you will get at that point. One of the other key learnings that we want to also share with you today is that we identified that incorporating human in the log processes, that means bringing in local communities, local authorities to actually validate the results of these models, and also training, like identifying new data points as samples. Let's say if you're a member of your community and you might be walking around your neighborhood, you might actually identify that a new location of an illegal dump site just emerged. So you could somehow report that, and we could feed that into the algorithm with a new imagery from that specific site. And the idea behind this is that the models will have that capability of incorporating the human in the loop processes to improve their performance. So that's one of the key things that we also looking forward to implement in the future. And if you are into that space as well, we would like to hear from you if you would like to collaborate in that regard. And then the last key point that we want to also share with you is that we have seen there's like some kind of tendency currently in terms of open architecture. So that's well known currently as digital public infrastructures or digital public goods as well. And the idea behind this is how we can utilize either open software, open data, or open algorithms to deploy architectures that an analogy will be somehow as having infrastructure like a highway where different key stakeholders could connect and somehow consume the results for their own purposes. So we can imagine that we envision this kind of open architectures where local governments are able to both consume and utilize the insights of this kind of innovations fed by computer vision and artificial intelligence algorithms. But at the same time, these local actors can also feedback these algorithms to improve their performance and specifically adapt that not only to a context country-wise, but rather at a municipal level or even lower at a population or community level. So this is something that we are also envisioning, and from UNDP taking some steps in terms of contribution to digital transformation in the country. So that's pretty much it for that. There's just like one last key resource that we want to share with you. If you might not be aware about that, we actually released a technical paper about this recently, just about a month ago. So if you're interested, you can scan this QR code so you will be able to download that and read more about that. Our contact information is here, and I'll open the floor for any questions and comments you might have. And again, we're just at an initial milestone where we have reached in terms of having this kind of like, this computer vision and artificial intelligence model that can detect illegal dump sites for the context in Guatemala. But we envision these next steps in terms of scaling that up, emphasizing that we utilize low-cost technologies as well that can be easily adopted by local authorities and communities as well. So we invite you, as Rose, our deputy representative in UNDP Guatemala mentioned at the beginning, we invite you to be part of this journey and feel free to reach out to us. Over.
Let's say about the QR codes. I don't know why it's not working.
If it's not working, we can paste the link in the chat right now. And we can already see that some people have write some questions. So Martin, if that's okay, I'm going to be addressing the first one. And if you see others, please feel free to address the others. And if anyone wants to open their mic, I believe there's also an option where you can raise your hand or let us know and we open the mic for you. So there's a question from Lexi Bauer, I believe, from USAID, if I'm not wrong, Digital Development, GIS and Data for USAID based in Guatemala. And she's asking two questions. One is if there is, there's a program actually locally called Ocean Cleanup. And she's asking if there's any plan. Sorry, I don't know if you're Lexi's, I'm assuming it's a woman. I apologize if I'm wrong about that. If there's any plan to work already to collaborate with them and to identify where they could implement based on where the dump sites are identified. From UNDP Guatemala, we have actually had some exchanges with Ocean Cleanup. And yes, there's actually that possibility based on this type of analysis. we could somehow understand the areas at a higher risk with higher degree of concentration of illegal dump sites. So intervention like from ocean cleanup can be better somehow targeted in terms of the geographical area and specifically in where in the Motagua River though that kind of actions could be incorporated. Then in terms of your second question, you're asking if there is any connection with local authorities to address through regulation or legal protection. We are actually in contact with some local authorities, like the authority that is in charge of the protection of the Atitlan Lake in terms of how we can implement that, like these kind of solutions for their specific, let's call it like ecosystem, and where the geographical area is very particular because it's very steep and very difficult actually for local governments to access that. So having satellite imagery and utilizing this kind of models could actually help that. But in terms of the regulation, that's something that we haven't taken any. We are not there yet, but we will be happy to learn more, or in case you have any leads on that, let us know as well. Let me know, Martin, in case you also see any questions that you might want to address. Over.
Thanks, Carlos. I already answered most of them in the chat, I think. But I would also like to give the floor to any other questions if there are any. In any case, we are very happy to connect with you. If you want to know more about other projects and our work, we are very happy to facilitate a meeting and talk about other ideas. Just reach out to us, or if you have any questions, also let us know. We are happy to answer. There was actually one more question regarding the repository and the data. Is it already open for public, or are we still working on that?
Yeah, so in terms of the data, we have used as training data location data that has been shared with us by the central government, the Ministry of Environment. So that was pretty much like our training sample. And then we included some additional observations to pretty much like put together the validation data set. But in terms of the model, that's something that we're also like working on currently in terms of how it could be easily could be shared with other like regions or other authorities or key stakeholders, so that could easily be transferred to other regions, at least in terms of UNDP. If there's a UNDP local office in your country, in your area, that's pretty much we can confirm that that could be easily shared through our UNDP offices and for doing some experimentation and testing. And then as a next step that we're analyzing and just seeing how it's possible, as we mentioned, the idea is to offer or promote these open architectures. So we do envision that like putting either releasing the model as a open algorithm, that's something that we need to check internally, or releasing some sort of infrastructure, like an architecture that you could like easily utilize within your organization. But as Martin say, if you have a specific case, like from a specific geographical area, and a specific application that you might be interested, feel free to reach out so we can have a more detailed conversation on that. Over. I see also a question from Sebastian Peña. Yes, Sebastian is actually highlighting that this work was also presented at the UN World Data Forum last year in Medellin. And we presented also like the recent advancements of our work. He's asking about the costs that this project has. And he's asking also on ways on replicating this project in other territories like in Colombia. Yes, so that's a really good question. In terms of cost, I don't know, Martin, if we can, well, we have a rough estimate, but in terms of the cost, that's actually not a very large budget that we actually have spent on deploying this. It's actually like a relatively low budget in the scale of just $1,000, right? You don't need like $100,000 for deploying this. And that's also because we have deployed our internal capacities within also UNDP, both from UNDP Accelerator Labs and SDG AI team as well. And one of the key goals, as Martin mentioned at the beginning, is that we wanted to deploy a low cost and effective solution that could be scalable. Okay. So right now we have a good enough model that you wouldn't need actually to go through the whole architecture process, but rather actually just retraining your algorithm based on data samples from your own geographical location if it's possible. But if not, the way it's working right now, you could even test or experiment with, let's say, imagery in Colombia, in this case, that actually the geographical aspects and characteristics in Colombia are relatively similar to Guatemala because we're closer to the equator. So pretty much our Central American and South American region, specifically Colombia and so on, they have like similar geographical characteristics. So that could actually be an interesting experiment to run as well. And if you might be interested about that, again, we have presence as UNDP in Colombia as well, and we could talk more about that. So there's also a question, I don't know if you addressed that, Martin, from Pablo. He's asking if crowdsourced pictures being considered to be incorporated to the model and if to have any additional perspectives. Actually, that's a great idea. And yes, we have considered that even for next steps as well, in the sense of we have another partner in terms of open mapping at UNDP, and even right now we just signed an agreement at the regional level in Latin America and the Caribbean. And the idea is just how we can potentialize citizen science and some very low cost technology for empowering like communities, like local citizens, populations to actually create sample data sets, right? So it's actually that's doable. We have the technology as well. We have partners around that. That's something that if you're interested also in having a conversation around that, that's something that we have identified as an opportunity. And the thing is that there are like very low cost technologies that could people in communities, for instance, could utilize to record and identify the geographical location of where that specific like new illegal dump sites are located. And then once we have that, we could easily utilize the low-cost satellite imagery for retrain and enhance the performance of the model in that sense. And then another similar opportunity is that also United Nations has a program on volunteers. It's called a United Nations Volunteer Program. And there's also the possibility of having on-site or remote volunteers and pretty much have that kind of capacity of hundreds of volunteers working on identifying, testing, or even validating the results of these algorithms.
Yeah. I think this was like an idea we were contemplating actually to implement, working with volunteers in the field. And this could be done technically. We just need to find people that live in areas that are prone to dump site dumping and are willing to spend some time outside and report this. So it's just maybe a question of scale. But in that case, it would be definitely possible. So I would be very interested in doing that, and also experimenting with more high-resolution satellite images. Sometimes the government or other stakeholders have some agreements in place that help to procure datasets for a better price. Also, UN actually has agreement with some satellite image providers for a one-shot implementation or an experiment. It's possible to get datasets as well. So there are some questions coming. Yes, crowdsourcing, I would say, yeah, this also comes very close to this idea of using the volunteers, make people aware of this and make them report data sets. So there could be some sort of a platform, maybe I could envision, where people can register and just upload evidence, maybe also using the smartphone of existing dump sites or trash surrounding their environment, the cities or villages they come from. So this is actually, if it doesn't exist, is also an idea that comes to mind.
Thank you, Martin. And there are just like a few last questions in the sense of scalability to other regions, like implementation in countries like in areas like Africa and Asia as well, and what will be needed, for instance, to retrain that model. And there was a challenge on identifying buildings, it says. Yeah, but the key point here, the key question is about generalization to and scalability to other areas. So.
Basically, to implement this in another country is what we need actually a few thousand locations of dump sites. And we need to know where these dump sites are exactly and when did they see them. So the best thing you can do is actually record available dump sites or like potential dump sites by using volunteers in the field in a like a short time frame as much as possible, because if you want to then later procure satellite images, it makes sense to see more dump sites on one image and not have to recruit one that is 1 month later or 2 months later, because the problem is that sometimes they disappear, they get removed, and it's much better to have this effort in a short time frame. So if you have that, you can definitely train the model easily, and actually that's pretty much it. Yeah. The model architecture will not change much. This is pretty much given. We just need more data. Yeah, I think you don't really need to get data for such areas, because if you get enough similar data from other publicly available places, the model should be able to generalize this information and then also find dump sites that are located in closed areas, for example, areas that are controlled by armed groups or for some other reason are not accessible. So this should be, this is the whole idea behind this machine learning approach, because this should be somehow able to detect all the dump sites in a country, even though you didn't go there in person. So it's automatically doing it instead of human intervention.
Thank you. Thank you for that. We also included in the chat, someone was asking, Fran was asking about the contact information and the best way to reach out to us. So we're including our team emails. Feel free to reach out to both of us, right? And so we can have further conversations on that. I know that we're on time, at the end, but I just wanted to take advantage to address some question that we might have missed. So there's one interesting one in the sense of the approach in places without secure physical access to the sites, right? And how to check the data independently. So actually, the work we have done so far in terms of training the model, deploying the model, and using the specific satellite imagery, you don't really need access to the site. For instance, if it's very difficult to access, either because of a security matter or maybe because of another type of matter, as long as you have some sort of idea, Martin was saying, if we know where this could be happening, the geographical location, and then the time, right? Then we can pretty much query a specific satellite imagery in that area and visually identify those specific area that will be fed, a specific image sample that will be fed to a model. Okay, so that's possible. So you don't really need access, just to make that point. Although yes, the validation or confirmation by third-party sources, that will be actually useful, and that's why we wanted to share with you this learning and that we're envisioning the human in the loop processes, and that could actually be anonymous as well, in case there's any kind of a risk of people that might be participating in those kind of activities. I hope that answered your question. And Martin, let me know if you see any other question that we might have not addressed, so we can then close this session over.
Thank you as well. I see one more question regarding microplastics in the ocean. I think I already sent one answer to this, but I'm also interested in learning more about this. So if there's some work being done currently and some research in the pipeline, I would be very interested in understanding how this can be applied to our case as well. So feel free to reach out to us and we can also have a discussion on that.
Thank you. So thank you all then for being here. On behalf of UNDP, sorry, there was a hand that was being raised. Okay. Well, thank you again. We do appreciate your time. We know that time is something that is a resource that we usually don't have anymore in our busy lives. But we do appreciate your time of being here, listening to us, allowing us to share our experiences, our learnings. And just we want to emphasize that from UNDP, following our UNDP digital strategy, and as well as part of this UN 2.0 week, as the quintet of change, right? And this more general UN vision. We do work in terms of pushing forward this kind of data and digital innovations in benefit of communities and the planet and aligned with the SDGs. So again, we do invite you, if you identify some sort of opportunity, interest, to reach out to us, to be part of this journey with us. And we're open for further collaborations. And with further ado, thank you and have a nice day and evening.
Thank you.